Okay, June 2017, number 22, two distinct acute triangles, ABC, DEF. Not drawn to scale. And what do we know about them? Let's see here. B congruent to E. I have triangles are congruent if there's a sequence of rigid motions that maps. Okay. Rigid motions, which tells me all these listings, all these pairs should be congruent if I'm going to produce a rigid motion from it. So if I go A to D and C to F, would that be enough to say the triangles are congruent? It better not be at this point, because I might just flip out. What method would that be? If I had already given B and E, and now they're telling me A and D are congruent because of rigid motions, and C and F are congruent by rigid motions, what rule would that be? Something that I would never write down to prove two triangles congruent. Angle, angle, angle. So that's out. All right, not away. AC congruent to DF. All right, let me mark it. AC congruent to DF, and BC congruent to EF. Oh, another one that fires me up. Is this a method? No, side-side angle is never away. All right, side-side angle, nope. All right, let's keep this train rolling. Let's see, C onto F. And I have BC onto EF. What do you think there, kiddos? What method is this one? Angle, side angle, and there we go. Got to be congruent. Good back there, Evan?
Yeah, on like the answer sheet, it was like it didn't put an answer.
What? Really? Look at that, huh? Maybe they had reasons for 1, 2, and 4 being, I don't know. But that's the one I would definitely pick, would be choice 3. But they got lucky on this exam last year because they awarded 2 questions, a couple choices. Don't plan on having that this year. All right. I don't know why 1 would be awarded, but angle, angle, angle. I'm sure there's some freak math about it, but. All right, others here. Going. Justin. 3, everybody. See what we're looking at here. Cosine of B is which function also equals? All right, when we're dealing with a right triangle, sine and cosine will always be the same if their angles are what? Complementary, right? They have to add to 90. They have to add to 90. So what they're asking here, cosine of B, and they tell me its angle C is 90. You guys tell me what's going to be complementary to angle B. What other angle should be complementary to angle B? Add it to the other angle and adds up to 90. Angle A. So the sine of A should be the same as the cosine of B. Always, always. They're only equal if the angles are complementary. All right, so sine of A would have the same value. Now, if you wanted to as well, another way to do this, without remembering that fact, ready? Hey, little review. Cosine of B, cosine, SOHCAHTOA, what's it equal to? Ready? Adjacent hypotenuse. So if you go through the choices right now, let's go through the choices. Tangent, what's tangent equal to as far as SOHCAHTOA? Opposite over, not 5 over 13. Keep going. Tangent, opposite over adjacent, not 5 over 13. Then we get to sine. What's sine equal to as far as SOHCAHTOA goes? Opposite over hypotenuse. There's 5 over 13. So that's the other way I could have done it. Next. Yeah. I didn't say C and B. No one said C and B are complementary. Okay. Do you see he's trying to take the award away from you? With the flow game? You're trying to take the flow game away from Rico, and it's not happening. It just literally looked like you just stuck your hand in an electrical socket and just walked into class. with your flow. You're trying to take it away from Rico, but I don't know. Okay. Good. All right. Just every time I look back there, it just looks like you're surprised every time. Just by the hair, it just looks like you're surprised. Never mind, Ethan, it's fine. Anything else you want me to go over? Yes, Saad. James, you're on deck. What was 24? Yep, 24. Which is not enough information to say they are similar. Would you guys mind real quick going over the 3 ways to prove any 2 triangles similar? Methods of proving them similar? Angle, angle, yep, 2 pairs of angles. What else you got for me? Side, angle, side, similarity, and side, 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 similarity. Automatically in the diagram, what pairs of angles are equal up there? The vertical angles, ACB and DCE, are automatically congruent. So I can keep that all the way through. All right, we ready? What if I knew that AB was parallel to ED? Do you know any more angles then would be congruent? Yeah, A and E and B and D, because they're what type? Ultra interior. So that's okay. Knowing they're parallel would make it those 2 triangles similar by angle, angle. Good. All right, so let's keep going because I'm looking for the one that doesn't make them similar. What if I knew that DE was 2.7 and AB was 8.1? Any of these methods up here? I'm not even going to check if they're in the same ratio. I just look where I put them. Right? This one would be, this small triangle, yeah, that might be side angle side, but not over here. Because this one's not, this angle's not in between those 2 sides. So there's no way, even if they are in the same ratio. Okay? Good. And then let me go over the other ones. CD being 3.6. Now I put BC here, 10.8. Now do you see that side angle side? And then what are they giving me here for the last one? So all 3 sides, yep. What do you got, James? You're up.
Number
18. All right. It seems like these have come up the last couple exams, huh? When you rotate a figure around and they ask you a question about their volume. All right, my first question is, when I revolve this right triangle around AB, make sure you knew it was AB and you're not revolving it around AC. What 3-dimensional object will I end up getting? That is a cone. Yep, that is a cone. Formula sheet, volume of a cone, 1/3 pi r squared times the height. Okay, so if you imagine it here, the cone's going to look like this, where this right here is AC, that's 4, and here's going to be that side AB, which is 6. There's that right triangle right now. Okay, going to be revolved around. So now plugging it in, you guys a little help here. 1/3 pi, what's my radius? 4 squared, and how about my height? 6. And it's in terms of pi, so I'm going to multiply 1/3 times 4 squared times 6. We see how we get that cone? We okay how that cone and the radius is 4, not 2. Anything else there, kids, we want to go over? All right, you're going to have to remind me what we have and have not gone over because I'm at different spots with different classes. Let's go to yesterday's. Did we do 31 yet? Well, let me back up. Did we do the sequence of rigid transformations here? Did we finish 30 yesterday? We didn't finish it, right? I think the bell cut me off with 30. How far did we get with 30? Well, we didn't get anywhere.
We got to along vector.
Okay, so we talked about we had to rotate it, correct? All right, so rotate triangle ABC. We can't give a degree measure. There's no chance of a degree measure, but when you tell me to rotate, can you tell me where you're rotating around and in what direction? So what point did we pick? C? B? Okay, so rotate ABC around point B. And we gave a direction of clockwise. So point B staying where it is, and we're rotating point C and A around it clockwise direction. Then we said, all right, after I rotate it, it's still not on top of triangle DEF. What other transformation should I apply to get it on top of each other? Translation, all right? Followed by a translation along. Now, here's the catch. What point did we rotate it around? B. So that must mean you have to translate it along vector B to its corresponding point. What point corresponds with B? D. Yes, B and E. Excuse me, B and E. So translate along vector BE. If you chose A, what vector would I translate along? A, D. Okay, so it does matter what point you rotate around. We all good there? Okay, let's go to 31 then. Let's go to 31. So you have this line, 3x plus 4y equals 20. We're going to dilate it by 1/3 around 4/2. Quick question, am I allowed to just go ahead and multiply everything by 1/3 here? No, because it's not dilated where? Around the origin. It's a new point. Can you guys do me a favor real quick? See if you can graph that line, because this question is going to be a lot easier for me to talk to you about if you can see what that line looks like. So let's get it into y equals form, and then you guys can rep a graph with it. So move the 3x over. So we're looking at -3/4 x plus 5. You guys are going to graph real quick for me. Hopefully I don't have to show you how to graph that. -3/4 x plus 5. I'm good enough. Actually. Can I do that? No, I don't think so. Okay, there's the line. What's point am I dilating around? Why don't you take a little look where 4/2 is? Take a look at where 4/2 lands. Where's it land? 4/2 lands 1, 2, 3, 4. Oh, 4, 2, right on the line. And does 1/3, a scale factor of 1/3, tell me, am I going to get closer or further away from 4, 2? Closer, right? So, all right, let's just take a random point right now. I'm going to take this point. It's going to get 1/3 of the way closer. Where does that point still land? It still lands where? On the line. Let me take this point way over here. I'm going to get 1/3 closer. Where's it still going to land? I keep doing this and doing this. All my points are still going to land right on the line. So what's my new line going to be? Same as the original. All right. If your center of dilation lands on the line you are dilating, it does not change. The line does not change. Okay. So my new equation, did I give a name for it? P. Thank you. Line P. So line P is equal to, what do we say? You can do the original or the converted one. I'll do the original. 3x plus 4y equals 20. And it does say explain. So because, what'd you notice about your center of dilation? Because the center of dilation is on the line. There's only, if you're going to dilate a line, there's only two options. It'll be through the origin. And what are you allowed to do if it's through the origin? Multiply by the scale factor. Or it's going to be on the line. And if that case, just like you saw in this example, the original and the image stay the same. Questions? All right, I have one I want you to do either in your group or try it out by yourself. And that is number 34. I'll give you guys about 2-3 minutes right now to try that out. Bounce ideas off each other if you need to. And then I'll have a couple people explain what the deal is here. I think this is a very, very good question for you guys. So about 2-3 minutes, check it out. Bounce ideas off each other if you need to. You can do all the computations. Inside the tank, when it's inside the tank, what's that metal pole acting as? That's my what of the cylinder? That's the diameter of the cylinder. So our goal right now is somehow find the diameter of the cylinder and then add on 1 foot onto it. And a lot of you guys are choosing volume, which is good because it's saying it holds inside 20,000 gallons. So if a lot of people went to their formula sheet, pi r squared times the height. But then there's a problem. I see people for the volume plugging in 20,000. That's in what type of units? Gallons. And what's your length in? Feet. I can't have gallons on the left and feet on the right. I need to have everything in feet right now, and that is why they gave you this conversion. 1 cubic foot, which is the volume, is going to be 7.48 gallons. So now using 20,000 and the 7.48, now you need to find what the actual volume is in cubic feet. So now you guys can take it from there. Okay, guys, how you finding the volume? What am I doing with this 20,000 and the 7.48 gallons? Dividing them, yes. So you have 20,000 divided by the 7.48 at no time, and you guys know this by now, should I be rounding anything? 73.79679 cubic feet. So there's your volume. Pi radius I'm trying to solve for times the height, which was 34.5 feet. Make sure you're finding the radius, so you take the square root at the end, and then you're trying to find the diameter, so you want to make sure you double it, and then add on that 1 foot. I'm just going to go right to the end here. And we're going nearest 1/10 of a foot. But if you want to chime in, nearest 1/10 of a foot? 10.9 feet. Everyone there? We okay there? No big deal. Okay, I'm going to put this one to rest. There's a lot more questions we haven't answered. That's for you to review. Let's go to the January 18, the one you got as you came in today. Monday, by the way, that's your time, Monday. Anything, topics, even if it's a construction, I'll go over anything you want on Monday. Okay, anything you want. Any question from the exams, anything you guys need, I'll go over on Monday. That's your day. There's a couple in here that we have not talked about in ages as certain facts go, and I wanted to make sure I get to them. 9, everyone, 9. Anybody remember the rule here? I just want to know the rule, and then you guys can solve it on your own. Madeline, what's the rule here? Okay, name the exterior angle. Okay, so 180 minus 3x. Any exterior angle of a triangle is equal to? What about them? Yep, the sum of the two remote interiors. So 6x minus 40 plus x plus 20. All right, I know it's been months since we went over that fact, but all right, any exterior angle of a triangle is equal to the sum of the remote interiors. And please, hey, please do this for me. Just because you found x doesn't mean you're the winner. Go back, read what it's looking for, especially in this problem. It doesn't say what x is. It says, what's the value of BAC? Read, read, read. Guys, you can't leave until 2 hours anyway. I think most of you'll finish up before then. So go back and read, did you solve what was asked for? Please, please. Once you find x, you're not the winner. You got to find BAC here. Everyone all right with that one? Because I want to go on to some other facts here. 60 degrees, that's what it came out to be, 60 degrees. Need help solving it, plugging it back in? 16. Yep, it's a circle one. I'm trying to get through as many of these circle ones as I can because I know that went a little rough for us. AC is a diameter, perfect. And I got some chords and a radius MB. Which statement's not true? Not true. What do you think? Is ABC a right triangle? which means it contains a right angle. Is there a right angle in triangle ABC? If it is, where is it? Ella? Anybody want to tell me why ABC is a right angle? What's the theorem? Rico? Somebody's already in beast mode. Good, so that's correct. All right, that is a right triangle. ABM, take a look at ABM. Is it isosceles? If it is, back yourself up. Madeline, why is it isosceles? In a circle, all radii are congruent. It's isosceles. Let's keep going. Is arc BC the same measure as BMC? Anybody remember the type of angle BMC is? Hi, Katie. How do you find a central angle? It's always equal to its arc. And what arc belongs to BMC? BC. So they have to be the same measure. Now let's talk why is 4 not true? Arc AB is half of ACB. Well, what's ACB? Inscribed. How do you find any inscribed angle? You take half the arc, right? So where should this 1/2 be to be correct? It should be with arc AB. All right, the angle is equal to half the arc. All right, so that's why we're going to get choice 4 going. Are you all right there? Or maybe some of you remember that from your unit test. And 21. I don't know if anybody remembers this fact. Quadrilateral inscribed in a circle. Anybody? Quadrilateral? Because, hey, I know some of you, oh, it adds up to 360. That's just going to be an easy one. There's an X here and a Y here. Good luck with that. Got to know the theorem here. Quadrilateral inscribed in a circle. Katie? Opposite angles. Nah. Supplementary, yes. Opposite angles, supplementary, not congruent. Okay, opposite angles are supplementary if a quadrilateral is inside a circle. And this makes this problem a heck of a lot easier now, doesn't it? Supplementary, make sure you're adding them together. Don't set them equal. Don't set them equal. Add them together and set them equal to 180. And of course, they put the answer there that if you thought they were congruent, the answer is there. Savages, I'm telling you. And just so you know, choice 4 here. Okay. Your day on Monday, whatever you want to bring to the table for me on Monday.